Alright, morning class. I assume you've all gotten all your materials for the day and also copied your stuff to quick notes for the lecture today. So today we're going to do surprise, surprise. We're going to take concepts that we already know and we're going to expand them and turn them into new concepts, which we will next week take and expand into new concepts. Welcome to math. Alright, so we have FOIL today, which will be an expansion of a couple of concepts. First of all, let's talk about a reason why we would need FOIL, a reason why we would ever use it. Real quick, the easiest way I could explain we would ever need FOIL. How do you find the area of a rectangle?
Length times width.
Length times width, alright. Area equals length times width. So if I had a rectangle that was, I don't know, 3 by 2, it's not proportional, I mean it's not accurate, but 3 by 2, what would the area be?
6.
Area, don't just jump to 6. Well, give me the steps.
30 times.
30 times 2.
Yeah.
6. I know you're a genius, but I'm not. I gotta go with steps. I'm a little slower than you are. I apologize. So, alright, area is 6, right? So we can do that. Well, let's change it up a little bit. What if the area was x minus 3 and we'll say x plus 2. Pardon me, I apologize. So length and width. We'll say, I should actually change that. Just so the picture is semi-accurate. So x is an arbitrary number. It's an arbitrary figure. We don't know what the value for it is. It's just holding the place until we figure out what the value. Does that make sense? If x was 10, this would be 13, and that would be 8. So this figure still has an area. The area exists. So how do we find that area?
Multiplying length times width.
Length times width, right? So in this case, it would be what? X plus 3 times x minus 2, right? So we could actually find that area in terms of x. We could figure out what the area is. And we would do something like what you've done in your quick notes, which I will explain real quick what we've done. I just didn't want you to have to copy while I was talking to y'all. I thought it'd be easier if y'all already had the information written down. So looking at this real quick, and I'm going to do it once with the colors just to keep y'all caught up, and then I'm going to go back to black in interest of time. We got a lot of activities to do today, so I'm just going to write in black. If y'all want to keep using the colors to help you stay focused on which one's first, outer, inner, and last, y'all can do it, but I'm going to just use black after this first example. So what we've got is we've got the first. You multiply, it's a variation of the distribution that we learned back in the first chapters. What you're going to do is you're going to distribute every term here to every term here. And the way we'll do that is we'll use the FOIL technique. FOIL is just a neat little term that stands for first, outer, inner, last. So first thing you do is you multiply the first terms. So x times x, what do I get?
X squared.
Alright, next we'll look at the outer terms. So x times negative 2.
So minus 2x.
Minus 2x, very good. Alright, so next we're looking at inner terms. So these two. Positive 3 times x.
3x.
Alright, is it a positive 3x or a negative 3x?
It's positive.
Positive.
Alright, positive, right? Because a positive times a positive or a negative times a negative will come back positive, right? A positive times a negative will give you a negative. So, alright, if we look at, next we're going to look at last. So, this term times this term. Positive 3 times negative 2.
Minus 6.
Negative 6. Alright, so we've done our FOIL, we're there. We know we have because we got our little smiley face. We're golden. So, alright, looking at this, what do you notice about this? Is there something else we can do to this, or are we in simplest terms? Are we done?
You can combine those x's.
Right, because they're like terms, you can combine them. We learned that back when we were adding and subtracting polynomials in 7-4, 7-5. So we can combine negative 2x and positive 3x. What's that going to give us?
1x.
Alright, so I'm going to have an x squared, which can carry down since there's nothing to combine, a positive x, and a negative 6. Does that make sense? Because there's nothing to combine with this or this, but these two combine, and a positive 3x, negative 2x. Just like we talked about putting apples with apples, oranges with oranges. If they look alike, if they're like terms, if they're identical, then we can combine them. And don't forget, this is a common pitfall. Don't forget that minus 1ba, those are like terms. It's an AB, it's an AB. Commutative property lets us switch them. Don't forget those are like terms. You can combine those. So that's basically your FOIL method. You just do the distribution. You get there, you combine like terms. If you don't like that method, I've got one more I'm going to show you real quick that a lot of people like a whole lot. This will actually allow you to do things that are bigger than just a binomial times a binomial. I can take the same things and I'm going to have x plus 3 and x minus 2, and I can actually put it in a grid. I can do, x minus 2, x positive 3. Does that make sense? And then I can just combine them like that. I can do the x times the x, and I can get the x squared. X times the positive 3, and get the 3x. X times the negative 2, negative 2x, and my negative 6. Does that make sense? I got the same numbers I have here. X squared, negative 2x, positive 3x, and negative 6. I could look at that and say these are the same, so that's going to give me a positive x. So the terms I have in here, in my square, are actually x squared plus an x when I combine these minus a 6. Same answer. Does that make sense? So the area of this figure that we looked at earlier that I just erased to make room, no matter which way you do it, it's going to come back like that. The FOIL method is the way that they like to teach you. This method is good. It also works if you have something like, say you have x squared plus 3x plus, I don't know, 4. You could actually use this method to expand it out and go beyond the point of FOIL, which is actually what we're going to do next. I'm going to show you how to go beyond the thought of FOIL, beyond the concept of FOIL into a bigger concept. But first, let's make sure you can do the FOIL concept. Let's make sure you do have an understanding of it. Just digging through with either one of these, whichever one you like, whichever one you enjoy. I'm going to have you all group up. And this first FOIL factoring honeycomb activity, you're going to use the one that looks like this, and then the one that has the hexagonal little pieces on it. What you're going to do is you're going to take this one, and on the top, put the arrows that say FOIL going up, right here. And at the bottom, put the arrow that says factoring going down. And what you'll do is you'll take each one of these. If you notice, it'll have either an answer like this, or it'll have a beginning point like this. Each one of those, what you'll do is you'll FOIL it, and you'll figure out what the solution is for each set of binomials. You'll figure out which polynomial actually goes with it. You'll line them up so that each one is correct, and you'll fill out your honeycomb. You can work in partners, you can do this together. Just make sure that you can get there, make sure it's correct, make sure they all line up. This will be a whole lot of real good practice for you. And then we'll get back together. We'll all look at going to one step farther with it as another lecture group. And then we'll go a little farther with it. So here you go. Group up and we'll get this all passed out.